what will happen is it will video my, it'll be a screen record of my screen, and then the audio will just be the noise in the classroom, which if I'm close to my computer, you'll hear my voice loud and clear. So you'll get a full reproduction of class. And I'll post that video. There'll be a link in Blackboard of class videos. Okay, and I make a YouTube video out of what we did in class. So we are rolling on our first day here. And so Usain Bolt is still he's still the reigning king here of, he's the fastest man, right? You live in a time when there's someone who's way above his time. They said if you look at the graph of the 100-meter dash times, the time that he got in Berlin, which was, this is what I'm going to show you, like what was that, 6 years ago or something? He should have happened according to the trend in like 2050. So he's like way ahead of his time. He's an anomaly. And so here I've reproduced his race. So I've used GC here to reproduce his race. Okay. Not as exciting as watching it actually, but okay. And so he ran in the world. This is the world all-time record for 100 meters. He ran the 100 meters in 9.58 seconds. That's fast. If you need a couple extra, I'll just give them to you on the way back. Who else needs one? So how fast did he run? If he ran 100 meters in 9.58 seconds, how fast did he run? Don't look at the paper. Okay. I got it. Just one? Okay. So don't look at your paper. I think I handed it out a little too soon. So if he ran 100 meters in a time of 9.58 seconds, how fast did he run? How fast did he run? Yeah. 10.44 meters. You're reading your paper. You're right. Yeah. So how could you not read your paper, right? I just handed it to you. So yeah. So 100 meters in 9.58 seconds would be 10.44 meters per second. 10.44. So any of us could do that calculation, but the real question is, what does that number mean? 10.44 meters per second. What does that mean? Anyone? What does the number mean? 10.44 meters per second. Go ahead. Was that a hand, kind of? Okay, what's that? I mean, but what's the 10.44? Yeah. Okay.
So that's the average. He ran an average of 10.44 meters every second.
Okay, what does that mean? Yeah.
That if someone else were to travel the same distance in the same amount of time,
Yeah.
they would have traveled. Help me. They would have traveled.
Equal time.
You're
saying it's running at different speeds, but that number 10.44 is if someone were to run that same distance,
yes.
But at one constant.
Okay, go ahead.
I mean,
Same thing.
to simplify it is that for every change in time, he runs. I mean, for every change in time, he runs 10.44 times that change in time.
Okay. You're shaking your head. You have something else?
What you just said would have been close to if he'd been running at a constant rate.
Okay.
We don't know he was running at the same speed the whole time.
Okay, good. So yes, so people are talking about a constant speed, right? Did he run at a constant speed in the race?
No.
Do we know for sure he didn't?
He's huge.
How do we know for sure that he didn't? He starts. You can't go from 0 to a speed without changing speed, right? Or else you would die. Okay? Because your acceleration would be infinite, and that would be an infinite force on your body, right? If you go from 0 instantaneously to another speed, the force on your body is infinite. Because force equals mass times acceleration. Acceleration would be infinite, so the force on you would be infinite. Is there another comment? Okay.
Would it be for every second past he traveled?
Okay, so here's another suggestion. For every second passed, he traveled 10.44 meters. No. You say no. Why? What's that? No, you were shaking your head. Yeah. Why? So why? Why are you saying no?
Because he wasn't going at a constant rate. So you're saying for any interval in 1 second.
Okay, but this is the number we get when we take his 100-meter dash in 9.58 seconds. We get this 10.4 meters per second. But now you're telling me he didn't run 10.44 meters per second.
Is anyone close to the right answer?
I'm not saying right or wrong here.
Why would you say that for any small change in the time or seconds that the change in the distance was 10.4?
Usain's?
Yeah,
For any small change in time when Usain ran the race.
the change in the distance he ran was 10.4.
What do you think? Agree with that?
No.
Every change.
Doesn't that go back to that he ran 10.44 meters every second also then? Okay, it sounds like some of you have grappled with this before and are on the right track, but maybe not everyone has. So I have a little investigation here. There's 4 or 5 questions here. Oh, sorry. So here's something that might help. Here comes Emma. Go, Emma. She's going to beat him this time. I know she will. Go, 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 go. Oh, it's a tie. Again. Okay, maybe this next time she'll get. Here we go. Okay, you can do it. You can do it. You can be the fastest person alive. Go, go, go. It's a tie again. Okay, so I got some questions for you. Questions 1 through 5 to help you make meaning of 10.44 meters per second as Usain's speed. So this is that 10.44, that was Usain's speed. We want to make sense of that. So these are discussion questions, so you're going to talk at your tables as you go through them. Okay?
Or we can like put something underneath the leg. No, you can't hold it. She has a constant velocity. We're talking about
Oh, it's like halfway. I feel like you should put it more on the I put sugar on it.
I put cardboard. Try it. It's gonna taste as well. You fold it in half.
question.
Yes, sir.
It's real simple. For the sake of my handwriting is terrible, are we turning this
No,
in?
no.
Okay.
I see how many make letters. I need math.
So the purpose of here is to show. Oh, yeah.
No longer sorry. I saw it go, but I was like, she didn't say anything. It didn't hurt.
So for the first one, what is the purpose of Emma? So to show one, shows that you say is not translating at a constant speed.
Do not go into part 2. So our goal is to understand the 10.44 meters per second before we go on.
We beat over it so much. That concert piece is like
What's the, be more specific. What do you mean net result? Be more specific. Yeah, so be more specific. What end result? What is the end result? Same what? So that's better because so end result is a little vague. Okay, so what distance did you say in Emma travel? Both traveled the same distance, 100. How many seconds? Same amount of time, right? Okay, and we know that Usain's average speed was 10.44. So what did you say was the purpose of having Emma in the animation? So as I call on you, I'm going to ask you to say your name first. It's going to help me learn your names really fast. So anyone want to offer up what did you say the purpose of Emma was in the animation? Tell me your name.
My name's Joey.
What is it?
Joey.
Joey?
I have no idea if this is right, but I said that Emma's purpose was to show that they shared the same velocity regardless of acceleration, so that shows that they spin at the same time.
Okay, so shows that they had the same velocity.
Yeah. Even though
So
their accelerations were different. So
you were going to say, do you agree with that?
Actually,
What's your name?
Shanley.
Shanley.
Mine is different. The purpose of Emma is to show more. It also shows that Usain wasn't moving at a constant rate.
Okay.
That his speed did fluctuate
Okay.
throughout the race.
All right. So it shows that his speed changed. Okay. Does it show anything else? Does Emma show anything else? I didn't know. Okay. Go ahead. What's your name?
I'm
name's Morgan.
Morgan.
This probably isn't what you're looking for, but at one point it showed that it was saying it's actually going faster than Emma, and at one point because he's behind her and then catches up.
Okay. So why did I put Emma in the? So yeah, so we know they're going different speeds. But why? What is the point of Emma having her there? Anyone else want to try? So tell me your name.
My name's Ron.
Ron.
She represents the average speed.
Right. So because when we get this number 10.44 meters per second, you guys all talked about it. It's a constant speed, right? It's a constant speed. There's only one speed that is. It's not lots of different speeds. It's only one. She's running at that constant speed. She's running at that constant speed. Okay? So what is she showing us about Usain's race? Because really the focus is on Usain here. Tell me your name.
Oscar.
Oscar.
So she's doing the constant speed, and it shows that given the same distance and the same amount of time, even though his speed fluctuates, hers constantly, they cover the same distance in that amount of time.
Okay, right. So she's showing what? She's showing the constant speed that will achieve the same distance in the same amount of time, which many of you have said, right? Okay, and that's what the meaning of that is. That's what the meaning of that number is, the 10.44 meters per second, right? We know he ran lots of different speeds. He didn't just run 10.44 meters per second, but when we do the calculation for Usain, that's what we get. So who can summarize what the meaning of that 10.4 meters per second is? Somebody new who has not spoken up yet. I'll just point at somebody. How about right here in the dark blue shirt? Yeah. What's your name?
Me?
Yeah.
Oh, Bianca.
Bianca? So what do you think the meaning of that 10.44 meters per second is?
I put the meaning in the total sum of speeds divided into seconds.
Okay, so is it a sum of speeds divided by the number of speeds? Is that what we're doing? Is that what we're saying here?
It said divided into seconds, I guess.
Okay. Tell me your name. Lauren?
I put the average speed of 10.44 meters per second is the speed someone would need to go in order to travel the same distance in the same amount of time as someone going at the same constant rate of 10.44 meters per second.
It sounded like both were going at a constant rate. Are both going at a constant rate? So the same as what? So it's not the same as someone going at a constant rate. So it's so who was that? So make your definition specific to this example. Can you change it? Just tweak your definition to make it specific to what we're looking at here.
So that 10.44 meters per second is the speed Emma would go in order to travel the same distance in the same amount of time as Usain.
Good. Right. Yeah. Exactly. Right. Okay. So yeah, and I heard someone say, "Hey, you've done this before. Where have you talked about this before?"
Back 207/MTE 210.
What is that? Is that your first MTE class?
Yeah, I was with Carlson and Thomas.
And you guys work in the Pathways curriculum? Is it
Yes.
working with Pathways? Okay.
It was like high school and
Algebra and geometry. Okay. Nice. Okay. So let's go on to part 2. So let's do the number 1 together. All right. So 70 miles per hour. What is the meaning of that 70 miles per hour? So somebody knew. What is the meaning of 70 miles per hour as a constant speed? Oh, right here in the dark blue shirt. Are you gonna chime in? No? Yes or no?
Sure.
Okay. What's your name?
Peter.
Peter. Tell me.
So a constant speed of 70 miles per hour would mean in 1 hour you would travel 70 miles.
Okay. So in 1 hour you travel 70 miles. What do you think? Is that a good meaning for that?
For every change in time, the change in distance would be 70 times as large.
You guys are so smart. All right. So go on and do. So So don't worry if you didn't hear it. Don't worry if you didn't hear it. Don't worry. Go on and do numbers 2 and 3. Do numbers 2 and 3. So the original response was, in 1 hour, you would go 70 miles. Okay? Okay, so at 70 miles per hour, then in 2 hours, you go how far? 40. In 5 hours, you go 350 in half an hour. And then 1/10 of an hour. And how far would you go in B hours? Okay, so you see that going 70 miles per hour means a lot more than you'd go 70 miles in 1 hour. It means a whole lot more than that, right? It does mean that. It does mean that, but that's not the broadest meaning. So who else can articulate the broadest meaning of 70 miles per hour based on what we just talked about? How about here in the purplish, pinkish shirt? What is your name? Yeah, long hair, right here in the second table, pinkish, I don't know what color that is. Maroon? Maroon.
I said.
I'm sorry, what's your name?
Oh, Sam.
Sam.
I said that like for every like change in time, it's 70 times.
What is 70 times?
Oh, the distance is 70 times larger.
Right. So that's like the broadest meaning, right? So any change in time, you'd go 70 times that change in time in distance, right? Or in miles. Okay? So then, what about number 4? Gas costs $2 a gallon. This is also an example of a constant rate of change. So who can interpret that? So I think we can just answer it verbally and go on. So, what's your name?
Angela?
Angela, tell me.
So for every gallon you buy, you're buying $2.10 times that. So you're multiplying $2.10 times every gallon you buy.
Okay. So you can only buy it in. You only buy 1 gallon. So how much?
So like for every gallon you're buying, you're paying $2.10.
Okay.
So you're multiplying that by the amount of gallons that you buy.
Okay. It sounds like you're only talking about 1 gallon of gas is what I'm getting at. So can you revise it? Does it have to be 1 gallon?
No.
Right.
So it'd be like $2.10 times every gallon you buy.
Right. But you're still focused on 1 gallon is what it sounds like, right? It's you kind of like you I think you understand it, but you're having a tough time articulating because you're focused on 1 gallon. So what behind you had an idea? What's your name?
Josh.
Josh.
I would say per X amount of gallons you buy, you are spending $2.10 for each gallon.
Yeah, so you can do still on each gallon. Which this is Morgan.
Well, don't you have to keep in the gallons idea though? Because if you just say for every part, you could talk about a pint, and then you wouldn't be able to multiply pints times $2.10. So
Okay.
you have to keep the gallon aspect in there.
But my point is, the focus has been 1 gallon. It sounds like each gallon, 1 gallon. Tell me your name again.
Laura,
Laura.
for every change in gallons, the change in cost is 2.2 times as large.
Okay, change in gallons. And so, what were you going to say?
What she said.
What did you say? Peter, is that right, Peter?
Yes.
Okay. How about in the blue hat? She's looking up at her hat. Teal. Turquoise.
Tamisha.
Tamisha, thank you.
Yes, I said buying 2.10 times as many gallons.
Yeah, so it's given any amount of gallons, given any amount of gallons of gasoline. The price for that, or the change in price, would be 2.1 times that number of gallons. Okay? Okay, here's another situation. Let's go on to part 3. Any questions on that? Let's see. Before we do part 3, let me show you something else that graphing calculator here. So this is actually something you're going to do, and I think this will be due in October sometime. And this is called marble drop. So let me zoom in on the screen a little bit. So there's some instructions here, and it says a fictitious marble gets a running start and falls at a constant speed. The real marble falls by gravity, and it starts the exact moment that the fictitious marble passes it. Given that the fictitious marble is speed, so that the real marble will tie with it. So you can change the initial height, where the real marble will fall from. That's the blue one on the right. And then if I start the timer down here, the fictitious marble gets a head start, and when it crosses the height of the real marble starts to fall, and it falls according to gravity. So it's something of a game or a question to say, okay, so what speed do I put the fictitious marble at so that they hit the ground at the same time? I need to make it a little bigger, but can you guys read that? Is it big enough to read? Okay. So you want to do it one time? So here I've got the height at 1575. And I just threw the fictitious marble speed as 200. And this speed per second. Okay, this is speed per second. So the initial height is 1575 feet. So then at 200 feet per second, the fictitious marble hits too soon. This is showing, then this shows when the fictitious marble hit. This is the fictitious marble's time from the starting height. So it hits at 7.875. Real marble hits at 9.895. So this should be pretty easy, but you can just do it once for fun. What's the speed that you need to set for the fictitious marble so they'll hit at the same time? So you can work together or work by yourself, whatever you want. So what speed should we set the fictitious marble so they'll hit at the same time?
The speed, and so it will be the FM speed. So it's the 159.20347.
And how'd you get that?
1575 divided by 9.893.
893?
Yeah.
895?
Well, I can't see that
I
far,
found
but it
3.
looks like an
895. Okay, so you were saying, and the reason you did that one more time? The reason you did that calculation?
Okay, the blue one, the distance and the blue travel divided by the distance and the blue split. So we got the
Distance divided by distance?
distance divided by time.
Time. Okay. So the distance that the blue one traveled divided by the time that it took to do it is going to be what? Average speed. And what's the fictitious marble? It is representing the average speed of the real marble because it's the constant speed. You want it to be the constant speed to travel the same distance in the same amount of time. So if I put that in there, it'll do the calculation for me. And here we go. Watch it. Ready? Hurry up. Hurry up. Boom. Okay, so I show you this because this is gonna be eventually something you're gonna design. You're gonna do your own, make your own version of this. Okay, after we need to learn lots about GC, but it's mathematics, right? So we'll just need some experience with GC, but then you're going to write the mathematics to do this. So there are command lines here, and so these are the first 5 command lines, which I'm showing you. But then there's many, many more command lines below, underneath the graph here that are actually doing the work. So this is just, we can set the speed. This is just setting up the situation, and then this is just displaying 2 variables, FM time, RM time. GC has no idea what those are. When I created this, I just created a variable. FM time is this character string that means a variable, and so that in that command line, it's just telling me what the current value of that variable is. It has no idea it's a time. It's just a variable that I've defined, and then according to how I've defined that variable, it's giving me its current value. Okay. So it's all mathematics. All right. So I thought that was very relevant to what we just talked about, and then it's just kind of a precursor to show you what we may do. So now let's do part 3. Here we go. On the back of your sheet. She said for any change in time, the change in the battery percent would be negative 3.25 times as much as that change in time. I see some nods. Okay, good. All right, nice. Okay, so I'm going to just show you, we'll just do a little bit here on GC, and next week we're going to get into it. We'll hit it hard running, learning the basics. So the first thing I'll do, let's plot those two. Let's create a graph showing some of these elements here, and we'll start with the points. So to do a point, you just hit Control-2, and it opens up this vertical bracket. And so what is the first correspondence point? We want our x-coordinate to be the time and the y to be the percent. So it will be, tell me?
Well, I just have a question. For Mac, would it be Command 2?
Nope, it's Control-2 on a Mac. But don't worry about that stuff now. Yeah, we'll get into all that because I'm on a Mac, and that's Control-2. Okay. So what's the first point? 41 and 35? Is that it? Okay. And so then I'm going to open up a new command line. So this is telling GC, I want you to graph this mathematical object, which is a correspondence point of an XY ordered pair.
Wait, did you say you wanted time to be X?
Yes, I'm trusting you. I'm not reading. Is this...
It's 35 minutes.
Okay, thank you. Extra credit. Catch my mistakes. Catch my mistake. I was just listening to you guys. So, is this right now? Time is independent. Percent is dependent. X and Y. Okay. So now I open up a new command line, and I want to also graph the other correspondence point of these two. 75 and 28. Do I have them right? So now if I hit enter, it's just going to display the mathematics I've given it. And here I've given it 2 points, so it's going to display those 2 points. And why aren't they displayed?
They're really high up there.
Yeah, so I don't have the right window, and so down here in the lower left corner is, we're going to get into all this, so don't feel like everything I'm doing you have to remember. I'm giving you a little just demonstration, okay, demonstration. Zoom out, there are my 2 points, and you can see I can change the color of those points, so make that first one blue, okay, and the second one is red. Okay, so now what I want to do is, I want to show, we're going to do number 3 now. So I want to show horizontal segments. I want everyone to work on this by themselves first. Okay, so by themselves, so you can get it. What mathematical statement could produce a line segment, which I want to display up here, that represents the change in time in the initial situation, so between these 2 time values. And so I want a horizontal segment. So first of all, can you imagine what I'm talking about? Can you just imagine it? Where would it start? At the blue point. And if it's representing the change in time, it would be? Okay, so it's going to start at this point, and then how would I draw at this, what I'm talking about? Which direction would I go? Right, so I want to draw a horizontal line like this. So I'm drawing it by hand, but I want GC to do it for me, okay? And that's going to represent this change in time. So I'll call it D. Was T the variable I used? Yeah. So I drew it by hand, so I didn't do it well. So what I want to give GC the mathematics to create that line segment. What am I going to put into GC? So see what mathematical statement would represent that segment right there. And if I give it the right math, it'll produce the segment. That's how GC works. If I give it the math, it produces the segment. So I want everyone to write it down. I'm going to come around and look at your answers. Everyone, go do it by yourself. So a mathematical statement. Okay, some people are using P. Does GC know anything about our variable P? No. Has no idea what P is. Has no idea what P is.
Like, what would you type in your graphic calculator?
Try to do it by yourself before discussion, okay? I just want to kind of see by yourself first.
But we want to find it. So we don't get to be so if you just grab one.
Oh, like this. Oh, you want it. That's cool.
I want GC to create this segment right here, this one. So just write down what you would need for that. Nope.
Do you know how to change the domain? I don't know how to type it in there. Like, this is basically how I would type it on there.
So then the question is, when you graph a segment, what are you graphing? What is it? An equation? Okay. A line with this restricted domain. What is a displayed graph? When you're looking at that, what are you seeing? What is it that you're seeing? What's your image of that? What is it? Yes, it's a segment. What is it representing? Okay, we've decided that it will represent a change in time, but aside from that context, when you see that line, a range of x values, a collection of points. Piecewise function. Is it a collection of points? Okay, and so the mathematics behind that is we're going to say we want to tell in a concise way, mathematically, which points those are. So what's true about all those points? Right. Y equals what? Okay, now is that going to draw us the segment? No, because it's going to draw, what will that draw us? For all x values, right? So we just want that's the mathematical statement that represents those points. The points we wanted, which was our segment, to represent the change in time. All the y coordinates of those points are 41, and we want these specific x coordinates between 35 and 75. So notice, it's not computer language. This is just mathematics. You give it the mathematics, it displays what you tell it. Yeah? Okay, so that's a good question to ponder over the weekend for a display. If you put less than or equal to or less than, would you get a different image or not? So, print the syllabus, get GC on your laptop. So, for this class, all right, listen up. You're going to want, hopefully you have a laptop. That's going to be the most efficient way to complete this course. Put GC on your laptop. Hold on a second. 1 second, as you're packing up, you stop talking. As you're packing up. You guys, can you stop talking while I'm packing? Thank you. You can pack up, just don't talk. Have GC on your laptop, and then the instructions are on Blackboard announcements. Read those really carefully. There's a little bit of complexity to it for some situations, so just read that carefully. Then print out the syllabus, and then get started on your first writing assignment for a week from today. Okay, have a good weekend.